An independent editorial defense analysis focused on Australia's strategic environment.
The quiet crisis within the Royal Australian Navy has rarely been about the absence of steel in the water. Rather, it is about the scarcity of personnel to crew it. This is a structural deficit, and it has now decisively shaped the future surface fleet. The selection of the Japanese Mogami-class design for the General Purpose Frigate program represents more than just a procurement milestone, or a diplomatic gesture toward Tokyo. It functions as a tacit admission. It admits that the previous operational model, characterized by large, labor-intensive platforms, has become unsustainable, not just fiscally, but against the current demographic reality. By opting for a highly automated platform that halves the standard crew requirement, planners have prioritized operational availability over the traditional preference for bespoke, on heavy multi-role capabilities. This shift signals a fundamental re-architecture of how maritime power will be generated in the coming decades. It moves away from the assumption that mass is defined solely by tonnage. Instead, it moves toward a definition based on deployable systems. From a systems engineering perspective, the core value proposition of the Mogami design is clear. It lies in the aggressive integration of automation, specifically to solve a human resource bottleneck. The Anzac class currently requires a complement of approximately 170 personnel to operate effectively. In contrast, the Japanese design achieves operational capability with approximately 90. This reduction is not merely an efficiency measure, it is a critical enabler for fleet expansion. Scaling the surface combatant fleet to the projected 11 hulls would be logistically impossible under the current staffing ratios. Therefore, the reliance on augmented reality and advanced sensor fusion is less about technological novelty. It is about the preservation of force structure. However, this reliance introduces a distinct operational vulnerability. A reduced crew size inherently limits the capacity for damage control, particularly during high-intensity conflict. While the system may fight the ship effectively, the human redundancy required to save the ship after a kinetic impact is significantly lower. This trade-off suggests that while the fleet may possess more nodes, the resilience of individual nodes in a degraded environment may be lower than historical norms. The configuration of the chosen platform also clarifies the intended doctrinal role. The restriction to 16 Mark 41 vertical launch system cells indicates that these vessels are not intended to function as primary air defense assets in a contested environment. Instead, the architecture suggests a focus on anti-submarine warfare and sea denial. The inclusion of the OPY-2 radar and the mine warfare capabilities inherent to the design point towards a vessel optimized for the complex littoral environments of the archipelagos to Australia's north. The decision to accept a lighter missile load implies a reliance on the Tier 1 Hunter-class frigates and Hobart-class destroyers to provide the air warfare umbrella. This tiered approach places a heavy burden on the data link network. If the General Purpose Frigate operates in isolation, its magazine depth becomes a limiting factor. But if viewed as a distributed sensor node, one that feeds targeting data to more heavily armed platforms or land-based missile batteries, the limited internal payload becomes less of a structural flaw and more of a specialized design feature. Furthermore, this selection must be viewed through the lens of the broader AUKUS framework, specifically Pillar 2. While Pillar 1 focuses on nuclear submarines, Pillar 2 is about advanced capabilities, artificial intelligence, cyber, and autonomy. The Mogami-class is, in many ways, a physical manifestation of these priorities. By integrating a Japanese platform that relies heavily on AI-driven command and control, Australia is effectively creating a testbed for future autonomous naval operations. So it opens a pathway for Japan to integrate more closely with AUKUS technology standards, potentially standardizing data architectures across the three nations. Industrially, the procurement strategy introduces a complex variable: the decision to construct the first 3 hulls in Japan before transitioning to the Henderson shipyard in Western Australia creates a necessary bridge. It bridges immediate strategic need and long-term industrial sovereignty. This hybrid build approach acknowledges that the domestic industrial base is currently unable to meet the 2030 delivery timeline. Yet, the transfer of technology and production methodology from a Japanese industrial culture, known for rigid adherence to schedule, to an Australian context, presents a significant friction point. The challenge is not just welding steel. It is about replicating a manufacturing ecosystem. Japanese shipyards operate with a distinct philosophy of supply chain integration and workforce discipline. Attempting to graft this onto the existing practices at Henderson carries the risk of cultural and procedural rejection. If the transfer is mishandled, there is a tangible risk of creating a 2-tier fleet within the same class, where the Japanese-built hulls perform differently from their Australian-built counterparts. This would complicate maintenance and training pipelines for decades. The alignment with Japan also has profound implications for the logistics and sustainment architecture. Operating a major surface combatant that shares a supply chain with the Japan Maritime Self-Defense Force creates opportunities for cross-servicing, and opportunities that simply do not exist with European designs. In a theoretical prolonged engagement in the northern archipelagos, the ability to repair and rearm at Japanese facilities would offer a strategic depth that cannot be purchased through hull numbers alone. It reduces the tyranny of distance, allowing Australian vessels to operate further forward for longer periods, supported by a friendly industrial base closer to the theater of operations. Financially, the program reflects a shift toward a high-low mix. With a target budget in the realm of 11 billion Australian dollars, the unit cost must remain strictly controlled. The discipline required to avoid Australianizing the design with unique modifications will be the primary determinant of success. Historical precedent suggests that the urge to customize off-the-shelf designs is the primary driver of cost blowouts. If the Mogami-class enters service with its original Japanese configuration largely intact, it will represent a victory of strategic pragmatism over technical perfectionism. Ultimately, the integration of this new class signifies a transition. It is a move away from a fleet designed for comprehensive self-reliance in every single hull. Instead, it moves toward a fleet designed for systemic resilience. It shifts the risk calculation from having too few highly capable ships, which cannot be risked in marginal scenarios, to having a larger number of adequate ships that can be deployed more aggressively. This restructuring is a response to a threat environment that demands coverage and persistence as much as it demands technological superiority. It places the Royal Australian Navy on a trajectory where the capacity to absorb attrition is prioritized alongside the capacity to inflict it.